couple of TikToks ago, I talked about how traveling close to the speed of light makes time move slower for you. I said that at 99.99% the speed of light, you can get to a planet that's 400 light years away in about 5.5 years from your perspective. Well, I kind of cheated there, as I skipped over a very important part, and that's how we get to that speed in the first place: acceleration. So let's revisit that and account for the acceleration using these slightly more complicated equations right here. Now we're going to want to accelerate at a rate that isn't harmful to the human body. So let's do 1g, which is the acceleration due to gravity on Earth. Continuously accelerating at 1g and just passing that planet, so no stopping, will take 6.5 years from our perspective, while 401 years pass on Earth. But we're going to want to stop there. We don't want to just swing by this planet. So let's accelerate half the distance, so 200 light years, and then decelerate the rest of the way. Doing this, a total of 11.7 years will have passed for us, while 402 years pass on Earth. We'll actually reach a maximum of 99.999% the speed of light at this rate. But there are much bigger problems that we would need to contend with. For one, we would need an outrageous amount of fuel to be able to sustain such a mission. And even assuming that we had that kind of fuel, we need extra protection on our spaceship. Remember, we're traveling at close to the speed of light, so everything that hits us is blue shifted. There are going to be tons of gamma rays hitting you. This is why in Star Trek, they use deflector shields in order to keep their spaceships safe. Then of course, there's the danger of your spaceship hitting dust. Even though dust particles are tiny, at those speeds, the energy of that collision would be explosive. So the reality of traveling close to the speed of light is actually a lot more complicated than simply how do we achieve those speeds.